Hi, if you like to understand what a function in mathematics is, you are doing the right thing by watching this video. Here I will tell you about functions, on practical examples, without boring formulas and tedious rules. In fact, function is not just a theory from mathematicians nerds, but a real-world thing. Functions live around us and we come across them every day. But we just don't suspect about this. Any, even most ordinary guys can easily understand what a function is. Well, let's consider a certain situation from the life. Imagine that you and your friends are going to chill out outside the city, in nature. You are the only person who has vehicles, and you are driving and you can pick up some of your friends. You are not a poor guy, you have a choice of motorcycle, car and van. If you ride a motorcycle, you can pick up one friend only, because a motorcycle is a two-seater. If you drive by a car, you will be able to take 4 friends, and 8 people can accompany you if you drive by a van. In other words, we have a characteristic, a number of passenger seats in the vehicle. That is how many friends you can pick up. And another characteristic is the total capacity of this vehicle. Let's draw this. This is a motorcycle. It is two-seater. The number of passengers is 1. This is a car. It has 5 seats, and 4 of them are passengers. And this is a van having 9 seats. 1 is a driver and 8 passengers. If we draw a line through these 3 points, we will get such a chart. It shows how 2 characteristics are related: the total number of seats and the number of passenger seats in vehicles. The dependence that shows how one characteristic is related to another characteristic is called a function. Any function shows a relationship between characteristics, between quantities. And this line is called a graph of the function. A graph can be of any form, it can be curved, not necessarily a straight line. Functions can be increasing or decreasing. For increasing functions, the second characteristic increases with the first one. The function graph goes up. For decreasing functions, the second quantity decreases as the first increases. The function graph goes down. And combined increasing and decreasing functions are also possible. This is when the second quantity either increases or decreases depending on the values of the first quantity. How can we set up a function? It can be not only drawn as a graph, but can be written in the form of table as well. This is an example. Here, each value of the first quantity has corresponding value of the second quantity. If we have a graph, we can always transfer the points from the graph to a table. Or contrary, we can always plot a graph based on numbers from the table. A function can be written also in the form of formula. This is the most convenient and compact way. For example, in our case, the number of passenger seats is always 1 less than total capacity of the vehicle. 1 seat is occupied by a driver. Therefore, the formula for our function is as follows. To find the number of passenger seats, you need to subtract 1 from the total capacity. To avoid describing the quantities in words, we can designate them with letters. One quantity can be denoted as x and the second one as y. It's more convenient, isn't it? No need to speak words. The result is a short, compact notation which is usually found in math textbooks. The letter y is the name of the function, and x is its argument. To emphasize that the function depends on argument and not vice versa, the argument is usually written in parentheses, in brackets, after the function name. X and brackets does not mean any specific actions. It simply says that a value of y depends on x. If we change x, then y will change as well. By the way, it's not necessary to use specifically the letters y and x. The function can be written in other letters, for example, f of x, or z of x, or z of y. Any letters can be used. What other examples of functions exist? There are a huge number of them. For example, in childhood everyone probably marked their height on the door frame or wall. At the age 3 you were of this height, and at the age of 5 you have grown up like that, and at the age of 12 you are almost an adult. As a result, we have two related characteristics, height and age. If age changes, height also changes. Age is x and height is y. Height is a function of age. Or for example, the price of gold is highly sensitive to its fineness. The higher the content of pure gold, the more expensive the item is. This is also a function. Bicycle moving is a function of pedaling speed. The faster you pedal, the faster you move. Or the more you eat, the less girls like you. This is also a function. And so on, millions of examples. The most important thing to remember here is that a function is a relation between quantities. And a function can be set up in different ways, in the form of graph, table, or formula.